Well, hello, class.
Hello. Hello.
Hello. Hello.
Okay, I'm glad everyone's with me today. So, here's another problem with the coefficient of the dy dx equal to 1, so we don't have to do any dividing. So plus y times cotangent of x equals 2 times cosine of x. So we already got that 1, so we don't have to do that, but we do have to find ourselves a nice integrating factor.
I agree.
So the integrating factor will be, this is our p of x right here, so e to the integral of p of x dx. So, how do you integrate cotangent of x? Well, you make cotangent cosine of x over sine of x, and then you answer the phone. So, now that the phone has been answered, e to the cosine x over sine x, do you remember how to do that? Let u equal sine of x, and du, of course, is cosine of x dx, so what we really have is e to the integral of du over u, which would be e to the absolute value of ln of u, or actually e to the ln of absolute value of u, which is e to the ln of sine of x. Let's just call it sine of x, okay? Because e to the ln of something is a something. So sine of x is our integrating factor. We multiply both sides by sine of x. We got sine of x dy dx plus y times cosine of x. Notice why it's cosine of x? Because this is cosine over sine, so the cosine over sine, the sines cancel. So we get sine of x dy dx plus y times cosine of x equals 2 sine of x cosine of x, which, by the way, is the sine of 2x. Remember, we're eventually going to integrate that side, so much easier to integrate this than try to figure out how to integrate this. So that's what we're going to do, and so let's do that.
I can't wait.
All right, so notice the left-hand side. Look here. First d second plus second d first. The left-hand side is the derivative of y times the sine of x. The right-hand side, of course, is sine of 2x. So we integrate both sides. Integrating the derivative, we just get this. There's an arbitrary constant. We're going to put that on the right. So in the integral of sine of 2x is negative. Remember, integral of cosine or sine is negative cosine, so that will give us negative cosine of 2x over 2 plus c. And now we divide by sine of x, because we want y. We don't want y times sine of x, so we divide both sides by sine of x. And now it gets a little bit more interesting. But it's just a matter of a few trig identities. Remember that cosine of 2x is 1 minus 2 sine squared. Actually use that to integrate sine squared in calculus 2. So that shouldn't be too far removed from your memory. So that means we have sine of x, that's this one over this. And remember, that's minus a negative 2, so 2 sine squared of x over 2 sine of x is 1 times sine of x. And then this negative 1 over 2 sine of x, and then c over sine of x gives us c minus a half over sine of x. And remember, c is arbitrary, so it's going to be y equals sine of x plus some constant c times the cosecant of x.
Nice work.
Oh, thanks.